Alright, we're now going to take a look at part 2 of graphing members of the log family. But in this video, we're going to take a look at adjusting both horizontal, all of these horizontal. We're going to have a stretch, a reflection, and a vertical translation. So let's go ahead and take a look at, first of all, what the parent graph of this thing is. In other words, I'm going to do this. I'm going to just kind of strip away this, 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 and this. I'm going to take all of those adjustments away, and let's take a look at what the actual parent graph is. This is a log base 4 of x is equal to y. That's what the parent graph is, all right? So let's take a look at what parent graph. Oops, I'm going to need to make some adjustments to this, so I'm going to put it down here where we have lots of room. Alright, so let's take a couple of maybe 4 or 5 points. We have a 0. Oh, excuse me, let me go ahead and do this. We have 4 to the y power is equal to x, right? We're going to write it in exponential form so that it makes it easier to create a table of values. So if the y is a 0, then we know that that x value is a 1. Alright, let's get larger with the exponent. So if we have a 1 here, we have a 4 here. If we have a 2 here, we have a 16. Again, if you've been watching the previous videos, this is the same function as before. If we have a negative 1 in the exponent spot, we're going to have a negative 1/4. Excuse me, a positive 1/4. If we have a negative 2, we're going to have a 1/16. Alright, let's get these on here. 1 up or down 0, over 4 up 1, 8, 12, and 16. I believe that's 16 too. Let me double check that. 2, 4, 6, 8, 10, 12, 14. Yep. Well, if I put it at 2, that would be really good. Okay, 16, 2, and let's see. We have a over a 4th down negative 1. There's that. And then we have over a 16th down negative 2. So there's the curvature of my log function. And I'm putting a smooth curve. Now that's going to approach the asymptote. I'll go ahead and put that, make that asymptote just a solid gray, a dashed gray line. There's the asymptote. Y equals, x equals 0. It's the y-axis, but it's x equals 0. So there's the asymptote that it will not reach. It's getting ever closer to it, but it won't reach it. Okay, so we're going to take a look at going back through here and taking these adjustments one at a time. Oops, let me put that back in there. And there's a particular order that we need to go through and make the adjustments, and so that we will have the correct graph. And so I want to really quickly run down the order of that, and that would be this. The order in which we adjust the parent graph is this. We first take the horizontal. We make any adjustment to that. Secondly, we make any adjustment to stretching. Oops, I'll go ahead and just write shrink. Shrink, stretch, or reflect. Okay, so that's the second. And the third one is we make any vertical shift. Whereas this is a horizontal shift, meaning a translation, and this is a vertical shift, meaning a translation. Okay, so the first thing we're going to do is we're going to take a look at the horizontal, and that would be this thing right here. Here's the adjustment for horizontal. Okay, now we know from the previous video that that just means that we're going to move everything. What? We're going to move everything. I'm going to go ahead and make this the black step, black pen. So this is going to actually move everything to the right 1 unit. Alright, so to the right 1 unit. Let me highlight that for everyone there. Okay, so to the right 1 unit. Now let's take a look at how we could just do that to the x column. So I'm going to make another x column here that's going to be the updated x column, right? So here we go. We're going to take every x value and we're going to move it to the right one, which would be what? Adding a 1 to it. So this is going to be 1 and a 16th. This is going to be 1 and a 4th. This one will be 2. You see what we're doing? We're just adding 1. We're moving it to the right one. Now, this red one is no longer valid. I'm not going to go back to that one because remember I'm adjusting these in a particular order. Okay, so I'll actually, here's my horizontal shift. It's already happened. I've made my horizontal shift, and from there I'm going to continue using the new X column. Here we go. Let's go ahead and put this one on, and that's going to be in the black color. So I'm going to have 1 and 1/16. I'm going to go over 1 and 1/16. I'm going to go down 2. There's that. Try to make that as large as possible. I'm going to go over 1 and a 4th, and I'm going to go down 1. I'm going to go over, you notice this is adjusting it 2 to the right, excuse me, 1 to the right. So I'm going to go over 2, up or down 0. There's that one. I'm going to go over 5, up 1. And then I'm going to go over 17, up 2. Whoops, pardon me. 17 up 2. Alright, here we go. Let's go ahead and sketch this thing. It's very much the same when we get way far, into the larger X values. But now look what happens. What is happening? This is still approaching an asymptote. So we're going to adjust our asymptote. I'm going to move the asymptote over. So now here's my new asymptote, right? Because it moved to the right one. Okay, there's my new asymptote. Okay, so there's the horizontal shift. Now, the next thing that we're going to do, let's take a look. We're going to do any stretching, shrinking, and reflecting. So let's take a look. Let's do the stretch, which is what is happening here. This right here is my stretch, and it's a vertical stretch by a factor of 2. Okay, so let's do that one. We're going to make that one a blue one. So it's a vertical stretch by 2. So that means that we're going to multiply all of the y values by 2. It's a vertical stretch. Every y value is going to get adjusted by 2. So let's take a look how we could write that as a column and just adjust those values, right? We had a -2 before, but if I'm going to multiply by 2, I'm going to stretch it by 2, then that's going to now be -4. I had a -1 times 2 is going to be a -2. 0 times 2 is going to be 0. 1 times 2 is 2, and 2 times 2 is 4. Now, no longer is this y column valid. So do you see where our new points are? We have 1 and 1/16, -4. Here we go. Let's go ahead and put those on in blue. Over 1 and 1/16, -4. 1, 2, 3, 4. Here's my new point here. Over 1 and a 4th, -2. There's that. Over 2, up or down 0. Remember, a stretch or shrink does not move it from the x-axis if it's sitting on the x-axis, or whatever point is on the x-axis. Okay, over 5. 1, 2, 3, 4, 5. Up 2. Okay, and then over 17. Up 4. So it was that, now it's that. So let's take a look at how this now appears when we put a smooth curve connecting the blue dots. Alright, now we didn't adjust, right? We're not adjusting our asymptote because we didn't move it horizontally. But you notice how that opened up the curvature? It's not such a tight curve. Well, that makes sense, right? It's a vertical stretch. We're stretching it out. Okay, let's go ahead and now do the reflection. Now here's this one right here, and I'm going to make this the green one. Now if it's a reflection, that means that what's up here is now going to be up down here. So what we're going to do is we're going to take all of our y values, and if they were negative, we're going to make them positive. If they were positive, we're going to make them negative. That's really simple. 0 has nothing to switch, and there we go. Now, no longer, right, are we going to use this y column. We're going to use the new y column. In other words, the reflection. So this is a reflection, right? Vertically. So here we go. Let's go ahead and graph our points. 1 1/16 is now, instead of down 4, it's up 4. So over 1 1/16, up 4. 1, 2, 3, 4. There it is right there. Really close there. Up 1 over 1 1/4, excuse me, up 2. There it is there. Over 2, up or down 0. Again, nothing changed there. And over 5, 2, 4, 5, -2. And then over 17, -4. Now you notice that before it was at +4, now it's at -4. Alright, let's take a look. Here's my reflection. My curve, smooth curve, is being reflected. Same asymptote, right? Same x equals 0 vertical asymptote. Alright, last one. Last one. Let's move the, let's shift it vertically by 3. So this time I'm going to, I guess I'm going to give it a pink one. I don't know what other color to highlight. So this right here now, right? This right here is a movement up 3. Up 3. Okay, so I'm going to use this pink and up 3. Now which coordinate, x or y, would be adjusting? Of course we're going to be adjusting the y coordinate, and we're going to move it up 3. So here we go. That's a 7 now. Up 3, that's a 5. Up 3, that's a 3. Up 3 is a 1, and up -4, up 3 is a -1. So again, this no longer is relevant, and our very last set of points will be over 1 1/16 up 7. Over 1 1/16 up 7. 1, 2, 3, 6, 7. There's that. We're basically just moving all the green points up 3, right? Over 1 1/4 up 5. There's that. This one is going to be right here. Over 5 up 1. Notice that moved the green one up 3. And this one is going to be right here. Let's take a look. There is my final answer in the pink. Now I could find my x-intercept there exactly, but I'm not going to worry about that right now because we're already at 12 minutes and 36 seconds. So I hope this was helpful. There is your final answer and final graphing of that logarithmic function. Thanks for watching. Bye-bye.